Hello, my name is Joe Brooks. I'm with MLC CAD Systems, and today we're going to be looking at some of the new features in Mastercam 2019. So for many years now, Mastercam has been giving us more and more tools that are all focused around doing the entire package from preparation and setup with your models all the way through validation and job documentation. So let's start this off with looking at some of the things we can do with the setup and the preparation. So starting in 2018, Mastercam actually added in the ability to use model-based definitions. Okay, there was one small issue though with the model-based definitions of 2018, and that is when they were imported, they were converted into lines, arcs, little splines, a whole bunch of geometric elements. So as we can see here, what you would have in 2018 with this import is you'd have 1,739 lines in one solid. Well, now when you import those annotations, they actually come in using Mastercam's annotation format, which means that they live as annotations. You can move them around, you can edit them, you can position them correctly, and they're not geometry, so you don't have to move them via transform. Okay. We also now have the ability to do a section view. So in the past, if you wanted to section a part, essentially you'd either have to copy your model and cut it in half, or use some other method, or if you cut your model in half without copying it, then every toolpath that you had associated with that solid model would of course turn red. Here we're going to look at a little example that's going to show how that can be slid back and forth by adjusting your plane dynamically, and you're able to see inside the part at any point that you would really like to. Speaking of seeing inside your parts, have you guys ever seen the IGES files come in that are missing faces, or maybe some of the faces aren't quite the way that you'd want them to be? Well, with 2019, we have the ability to do something called a power surface. Power surface is a creation tool that adds some intelligence to the surface creation that you have. And if that surface isn't quite what you want on those imported models, you can always edit it. Starting in 2019, you have the ability to actually edit the surfaces. They can be surfaces that were imported, or they can be surfaces that you created. Either way, you now actually have the ability to modify those instead of recreating them like we used to have to if they weren't the way that we wanted them to be. And we now have the ability to use hole axis on holes that are tapered. Not necessarily just those straight holes, but the holes that have any kind of taper to them all the way down to perhaps even a spot. And speaking of holes, you can now put holes with some intelligence into your solids. So in the past, when we wanted to put a hole into a solid, we would basically have to create an arc and extrude cut through. And then if we wanted a counterbore, we'd create another arc and extrude cut to a distance. Well, starting with 2019, you actually can just select counterbores, simple holes, countersinks, all of those things, including tapered holes, and put those in as features into your solid models. Let's take a look at a couple of these things over here in our Mastercam. So what we have here is a turn part, and we want to see some of the features that are inside of this. Well, what we can do is we can come over here to our View tab where this section view lives. Now, currently turning that section view on and off doesn't really do anything. The reason for that is that section view actually requires a little more information. If we come here onto our planes, we're going to see there's a brand new column right here called section. So if we want to section around any specific plane, what we need to do is turn that on as a section here, and then when we select section view, it will actually section it based on that plane. Now, what if you wanted to see more than one section? Well, we can actually section around multiple planes at any given time. So right now we have this sectioned around the top plane. What if we also wanted to add, let's try the right side plane also. Well, that's going to give us a thin little sliver because that's not exactly what we were wanting. Well, what if we said top as well as front? Well, that's going to give us a cut across the top plane as well as cut across the front plane, and we will end up seeing roughly a quarter of the part here. Well, that's great, but what if none of these standard views give you the section that you want? Yeah, it's not a problem at all. What we can do is we can come in here, we'll right click on our top view, we'll come down here to duplicate, we'll make it our section view, but then we can also right click on that and edit it. Now, with the editing, we can actually slide that back and forth and get that section exactly where we want it to be so that we can see the features that we want on that section. Okay, once we have that, we can select it exactly where we want, and we can still toggle that section view on and off right there. Now, even when the part is sectioned, you have the ability to select all of the geometry. As we're going to see here, when I select that outside face, the entire part shows back up. Now, that's because you're actually selecting the whole thing. The section view that we're seeing here is a visual section. All right. So let's look next at some of our surfacing things. So let's start here with the power surface. Now, what we have here is we have a part that's missing a couple of faces. So if we want to use the power surface, I'm going to come up here to our surfacing tab. Power surface lives under the create section. So we'll go ahead and select power surface, and I'm just going to chain around that, and I'll select OK. Now what we're going to see here is we now have a surface that not just matches the geometry, but it also matches the edges of the surfaces around there. So with a simple tool there, it's giving us the results that we wanted. Now let's look at this other section over here. Let's put a power surface on this one also. So we've got our surface on there, great. Well, that surface isn't quite what we want, because whereas power surface is matching the curve of this surface here and this one quite well, what we're not seeing is the shape in the center that we want. Well, we can actually correct that, because what we can do is use our power surface. We'll chain the outside just like we did before. But now what we're going to do is we're going to select these internal elements of geometry, and power surface will recognize that we also want that surface to intersect those. So let's go ahead and accept that, and we'll look at those results. So now we have a new surface. And this new surface not only lines up with the edges, it also intersects that geometry that we put in the middle. So once we get the result that we want, we can select OK, and that is our power surface. Right. Now let's take a look at the ability to edit some surfaces. So let's say that you brought in a surface, it's not quite what you want, or you've created it, and again, it's not quite what you want. Well, also under the surfaces tab, now we have the ability to edit a surface. So we will go ahead and select the surface we would like to edit, and we're going to get this gnomon here that we're going to drag across here, and it's going to kind of give us what we want. Now notice there's a couple different things going on here when we select, okay? When I select one of these arcs, you'll notice that the entire arc is selected. That's because it will use that entire arc as part of the modification process. If I just select a point, it's going to just be the point that's used. So let's take a look at this. I'll go ahead and select the entire arc here. Notice how that turned red. Now I'm going to pick the point at which I'm going to use to modify that. Let's go ahead and choose right there. All right, so once those things are selected, I can actually grab this and move it. And you'll see that it's moving with the entire arc. I'm pulling that entire arc back and forth because it's using that arc as a control feature. Okay, so we can drag that to where we want it. We'll put it about there, but you're not limited with just dragging it back and forth. You also have the ability to add twist to it. And you can see there how it's treating that arc now as a spline, and it's being twisted around that node point. So once you get that, however much twist you want to apply, you've got the surface the way you want it. You can accept that, and then you have a very organic and modified surface. All right, let's take a look at our next example here. And what we're going to be looking at is the solid where we can put holes in that the way that we want. So we've got a solid here that doesn't currently have the bolt holes that we want to put in it. So what we're going to do is we're going to go over here to our solids tab. Under the create portion here, there is hole. We'll select hole. And we're going to come down here and we're going to look at some of these options. So what we're looking at here is right here we have the template. We can select English, metric, or both. Let's go ahead and select metric right here. And under the category, we're going to say we want socket head cap screws. Okay, so then let's go ahead and choose the 3mm variety. All right, and now we're going to select the position. Where do we want these to be placed? Well, let's go ahead and add a point in right there at the center of that. Okay, now once I hit enter, I'm going to go ahead and see that counterbore hole that I put in there. If that is the one that I want, that's great. Now I can go in here and add more to it. I can add the other one right here. Okay, we get two of them now. That works great. Once you get those the way that you want, we're going to go ahead and say, okay, we have that. Now, one of the other nice things about the way this works is when we look at our solids here and we expand that, it actually put that in here as a 3mm cap screw hole. So it's going to label it for us based on what we had selected there, which is kind of nice for organization. Now, what if we decided, hey, later we actually wanted one over here too? We just neglected to select it. Now, do we need to go through hole again? No, we don't. What we can do is we can actually right click on this 3mm, come down here, say edit the parameters. And while we're editing those parameters, we can come in there and add another hole or modify them appropriately, give us the result that we want. And then we can go ahead and accept that, regenerate that because we've modified it. So we'll have to regenerate that solid. And once we do that, we now have all three of those just the way that we wanted them to be. All right. So let's look at our ability to orient our parts the way that we want. Now, one of the ways that we can do that is with the bounding box. The bounding box in 2019 has been improved with the ability to auto-orient to your part as well as create a plane while you're doing it. Now, when you're looking at those planes, if you don't want to just use the plane that you've created, you also have the ability now to align a part to a plane using the model prep, which now incorporates the align to plane, align to face, and the align to Z functions, all within the model prep. So we're seeing here how they're aligning a face and then adjusting it there. Model prep now includes align to Z. So align to Z is no longer just something that you would find within the lathe setup. Let's take a look at a few of these things over here in Mastercam, see how those things come together. So let's go ahead and open one of our samples here. We'll start with the bounding box, I believe. So this will open up, and what we're going to see here is we have a representation of a table and a part. Well, the bounding box that we're going to want to use is actually over here under wireframe, right here. So we'll select wireframe. We're going to select bounding box, and then it's going to prompt us, hey, select your part. All right, so I've selected my part. Great. Wait a minute. Now you notice here how I've got a rectangle or a square rectangle, but it's not what I want. It's flat against my plate. Well, the reason that that happened is down here where my construction is, I'm set to 2D. So as soon as I click that and set that to 3D, I'm going to get a box that is surrounding the part. Now, I can change the dimensions and stuff here, but the orientation isn't right. So let's look at under the Advanced tab. And under the Advanced tab, what we've got here is a couple of options. Down here under Orientation, right now it's set to Construction Plane. You can set that to Auto, and what it's going to do is find the largest flat or largest planar face on your part. and then use that for orientation of your bounding box. You can also specify a particular face if you'd like, or you can adjust that manually and get it in the orientation that you want. Up here, the options that we have is the option to create a new tool plane with a label, and then we can set that new tool plane as our tool plane and working coordinate system if we wanted to. But before we accept this, let's go back over here to basic, because when we create that new plane, we don't want to create it and then have to go back and modify it to put our origin where we want. So what we have here when we're looking at our bounding box is our origin. This will become the origin of the new plane once it's created. Let's say we actually wanted it to be this corner here after we create it. If we want to change our sizing, we can actually do that by typing in specific numbers here if we have a specific size we're trying to achieve. If we're looking to just put in clearance and things like that, we can actually interact with this live. We can come over here and grab that top, and we will pull that up by 50 millimeter. We can grab these sides, and we can adjust those one at a time and get those exactly where we want those to be. Once we have that set just the way that we would like it, we can go ahead and accept that. Now what that's done is not only has it created this geometry for us, but we can see it's created that new plane and put the origin in that back corner just like we asked it to do. Okay. So now let's take a look at, after we take those and get them into a bounding box, how can we actually align the parts? So let's look at some methods that we can use with aligning. All right, so when we're talking about the new aligning features, those are actually over here under model prep. And you still have align to Z, but now you also have align to face and align to plane. Okay, the one that we're going to look at right now is align to face. So let's go ahead and select align to face. And the first thing, piece of information it's going to want is select a face on the object you want to move. Now, order of selection here is important. So let's go ahead and select a face on the object we want to move. Now, before we select that though, it's going to be a little easier for us if we come over here and choose the method that we want. Do we want to make a move it or make a copy of it? We're going to move it. And then what kind of relationship do we want? Do we want it to be coincident, two things mated together? Do we want it to be perpendicular, or do we want it to be parallel? Well, we're going to go ahead and say coincident. And what I want is I want this face right here, and I want it to be up against this face of my jaw. Okay, so it's put that into position there for us. But now that it's touching, we need to do a couple more things. Like we need to correct our orientation, which I'll do that right here by grabbing that and rotating that around. I'll type in -90 degrees, so we'll get that just where the way we want it. And then that's a little too low in those jaws for what I want to do. So I'm going to go ahead and grab this axis and pull that up until it's sticking up above my jaw there like I want. Once that is in position just like I'd like to see it, I'm going to go ahead and accept that. Once I accept that, the part is moved, and we can see that that is in position the way that we wanted that to be. Okay. So now we're going to look at the align to Z, which was available in the lathe, and now it's available in the lathe setup as well as the model prep. So when we look at model prep here, we still have these in align to Z. We're going to take and select on align to Z. What it's going to ask us for is an edge of the solid that we want to align. So we're going to go ahead and select that edge. Now, once that's there, it's going to give us a preview. We can adjust our orientation here if we wanted to. So if we needed this to be lined up to a particular feature, we can select on that. You see how it's dragging up? If we wanted to align to the flat, we can align that to that flat. All right. Once that's done over here with our entity, we have some basic options. We can create a new coordinate system and then do all of our programming that, leaving the part in its current position. The other option that we have is to actually transform that to a plane. So now when we transform that to a plane, we're going to come in here and select the plane that we want to transform that to. In this case, let's put that into our top plane. We can switch our Z direction back and forth using this here. Once we get those settings the way that we want them, we'll go ahead and accept that. It's going to move that part, put it into position, just like we'd want it to be if we were going to do some turning, and set that up in our lathe. Now, speaking of turning and setting that up in our lathe, let's talk about some of the new things that come out for that, which is the big one, 3D lathe support for tooling. So now you can use your 3D tools in your lathe product and no longer use the wireframe DXFs like we used to. So let's take a look at that. So in order to accommodate the 3D tools, Mastercam's got an entire new tool designer for the lathe 3D tools. They've set that up with the top-down style of building so that you can start at the top, work your way down to the bottom, and make sure that you get all the information in there. It is also set up to where it will encompass all of the things needed for the tool. So not just the solid models. It also will allow you to put in your holders, your inserts separately. You can do all of your settings for feed, speed, coolant, all your parameters. You can adjust where it's going to be compensated for with this mating as well as with the profile. You can set it up so that you define your cutting plane, which way it's going to actually cut and how it's going to connect to the machine. You also have the ability to change where it's going to actually compensate on the insert as far as across the top and the bottom there. You also can put it into orientation like it would be on the machine, as well as define which particular quadrant and how that compensation works and is applied. And of course, you have all the rest of your parameters there. So let's take a look at that and see how easy it is to actually create one of those tools. So let's head back over here to Mastercam. When we go over here on our tool pass, we'll use this existing tool part that we have there. We'll open up our files here and I'm going to look at our tools. Now, what we have now is when we right click here in the white, the very first thing that shows up is now Create 3D Tool. So once we click on Create 3D Tool, it's going to bring up the new tool designer. And every time we see one of these boxes with the red halo around it, what this is telling us is that that information is mandatory. It will not let us move on until we've fulfilled the requirements of that. So we're going to go ahead and call this tool new, and we'll move down here to the next section, which is the insert. So again, red haloed box. What it's saying here is, hey, which model are you using for your insert? Now you can actually pull it from the levels or pull it from anything internal, but what we're going to do here today is we're actually going to open it from an external source, which is a step file. So we open up this step assembly, and what we have here is a holder and insert, but it's still red. The reason it's still red is even though we've opened this, we didn't satisfy the requirements of the box, which is select the model that we need to use for the insert. So we'll go ahead and select that. Once we do that, it's going to isolate it for us, automatically zoom in, and give us a good idea of what it is that we've selected. Here we can change the definition of this particular type of insert. Now, once we've satisfied the requirements for the insert, we can actually move down here and select holder. We're going to do the same thing here. We're going to open that same assembly. And now we're going to see it here, and it's asking us again, hey, what is the holder? So we're going to go ahead and select that. Now, if this clamp and screw were separate, you can actually select more than one item to be used there for that selection. So we will end that selection, and then we can move on to the next one, which is mating. So now that we have a holder and an insert, if this were not in position, we would be able to use that coincident, perpendicular, and parallel mating to put that into position in this holder. I would highly recommend that everybody, if possible, use pre-assemblies, things that are already mated together. It makes this portion quite a bit easier when you're going through it and saves you a few button clicks here during the creation process. Next, we're going to come down here and we're going to talk about the setup. Now, just because we put these models in here, there's nothing that is defined where it's going to cut yet. That's what we're going to do here by defining our cutting plane. I'm going to select this face here because this face intersects the cutting edge of the insert there just like we want. The next thing it's going to ask is, hey, how does this connect to the machine? Where is it connected at? Well, what we're going to do is we're actually going to rotate this over and select that back face. Once we do that, it's going to put it into a rough orientation for us so that we can see how it is set up. All right? Because what we can do here is actually change what it defines as up. We can also offset the tool in and out here. Next, we're going to go down to where that boundary is. So when we selected a cutting plane, it created a boundary for us. Well, if we needed to move that and change where it's going to compensate for the insert out, we could do that here. In this case, we don't need to do that. Now we're going to look at how it's set up on the machine. Is this tool set up in a vertical or horizontal orientation? Do we need to reverse it? Which turret is it on? Is it at a different angle? Which spindle does it use, as well as the spindle rotation for this particular tool? Next, going down the list here is going to be our compensation. It's asking us, hey, where is the compensation point for this particular tool? We're going to go ahead and select a point, and we're going to have it compensate to the center of the radius there. Okay. Once we do that, it's going to move it into approximate position for us. Right now, this is set up in quadrant 2. Now, when this is set up in quadrant 2, you're going to see out here on the screen, it's telling us that this would be the plunge direction, that would be the cut direction. Well, looking at that model, I don't think that's correct. So I'm going to go ahead and tell it that what we're actually doing here is compensating to quadrant 1. Compensating to quadrant 1 tells us our cut directions here, our plunge direction here. This does indeed look correct for this particular tool. So now let's go ahead and move down and look at the last one, which is parameters. Parameters is where we will define things such as what material is our insert made of, what kind of feeds and speeds we're going to have, what kind of coolant we're going to have, and other general parameters for that. Once we get that tool just the way we want it, we can go ahead and accept that. And that tool will show up here as our new tool. Now, what if we created it and then we're like, hey, that's great, but I need to make a couple changes to it? Well, when you right click on this and say edit the tool, it's going to take you right back into the tool designer where you can access and modify those, even replace the geometry if you wanted to. Okay? So once you get that the way that you want it, you can close those things and it works out the way you want. Now, we've just looked at some lathe tooling. I think what would go along with that is probably some turning. Let's start this turning off by looking at the Sandvik prime turning. All right, so you get with the prime turning, you have the complete 3D tools with assemblies and inserts. And what they've done is they've incorporated the prime turning technology into the actual Mastercam product. So as we're going to see here in this video, what you get where with the prime turning is they're actually using the long edge, the stronger edge of their insert, and they're going to be using that in a method that enhances the rigidity of the cut. And it's going to do that by pulling out along the long edge to set that up the way you want. And you can see they have roughing and finishing here within the same operation if you wanted to use it that way. And now we're going to see a little video here that's going to show what material is left and how that cut actually works. So we'll see this animation here. It's going to go in, plunge, and pull along the axial direction, which is where that tool has the most rigidity, is along the axis there. Doing that, it allows you to take some very heavy cuts and still maintain your rigidity, and it'll increase your material removal, making your parts take significantly less time. Another thing that we've added for this year is the ability to do multiple plunges within a groove. So in the past, if you were going to do your roughing of a groove, you get one plunge and then you'd get several other little plunges next to it. Well, the issue is when you side load your plunge or your grooving tool like that, what would happen is you could get some deflection and you'd lose some of your rigidity. So what we've done is they put in the ability, like we're going to see here in this video, to add in the multiple plunges. And what that's going to do is it's going to allow you to take several full width cuts, enhancing the rigidity of your tool, and then it will come back and clean those up. Now, you define those with your settings here, with your ribs, your rib setting, and then you also have the ability down here to have your automatic ribs, or you can set those up as a specified width or percentage of the tool. You can also come in here and define a specific peck amount if you wanted to have that as the peck plunging there. So, and you also can define your retracts along that as well. And the dwell. All that stuff is customizable within the parameters of that. And then as we can see here with the simulation, the way that it does this is it's going to do a full cut and then another full cut. And then after it's done with those full cuts, then we will start coming in and removing the material in between those. Just like that. Okay, now with the cross center line turning, before in 2018 and older versions, if you wanted to turn a cross center line, what you would actually have to do is you'd have to lie to it, essentially, and tell it that your tool is in an orientation that it's not necessarily in order to get the direction of your spindle to be correct. So what we've done with 2019 is we've added in the ability to actually define it with the planes, and it will automatically take care of reversing that spindle for you and getting it the way that you want it. As we're going to see here, you can set that up with your axis combinations, and it's going to reverse the spindle for you because it knows that you're going across the center line and that the spindle direction needs to be reversed. And then we're going to see that here in this animation real quick. Okay. So, Swiss machines. You can now program your Swiss machines Mastercam. Now you could before, but what we're doing now is we've got an entire library of posts for many of your popular Swiss machines. The nice thing about the way these are set up is in many cases your streams are automatically synced. You also have support for your full simulation. There are a few limitations that go along with this. And we also have the support for most of the popular machines, such as Citizen, Star, Ganesh, Swisstech, Tsugami, etc. Now, speaking of complicated machines like the Swiss R, we can see in this video here the simulation and the way that that's actually going to work with our Swiss. So we do have the ability to run that through and see all those cuts that we have on there. Just like that, we have simulated our part on a complex machine like that. Now, complex machines might lead us to think about mill turn. With mill turn this year, we have a couple things. The first one is the fact that now with mill turn, you have the ability to import operations from other mill turn machines. Now, before you couldn't do that. If you programmed it for one of your machines, you were kind of stuck with that machine. You couldn't actually change the machine or import operations to simplify the programming. Well, now you can. So as we're going to see here in the short animation, there is the ability to import those operations directly from another mill turn machine that did a very similar part. So just like in other versions of Mastercam, you're going to import those. You're going to select the machine. You'll bring them in. You'll reapply geometry, and you'll set those up and get those to run just the way that you want them to. Now, they've also added some extended options for your bar feed with mill turn. So now what you have, instead of your standard options here, you have the new options of incremental distance, distance from a chuck face, as well as distance from chuck jaws. And you can get that set up the way that you would like that to be. As we're going to see here with this short animation, we're going to see how the part is turned and then drawn out using some of those new options for pulling that out. We'll see there right underneath the bar feed, we'll have the option here to transfer the geometry. We can copy it to a new level that will show us how it's been transferred out. So then when we're simulating this with the mill turn product, we can simulate that portion. It will show us how it's going to feed out by the exact amount that we wanted to, the incremental distance there. And then we can go and continue on with our turning of that part. So we can program it to increase rigidity of those turning things just like we want. What we're seeing here is it's actually showing how you can pull that bar out an exact distance from your chuck face. Again, you also have the ability to do that from your jaws also. So for loading of the tools, they've actually made it quite a bit easier in 2019. And you can also adjust the projection incrementally with the drag here. So what we're seeing here is in 2018, if you wanted to load those, you would actually have to drag them down and place them inside the double station block. And then you could get that set up. It was pretty easy, but you still had to do that to get it to work the way that you wanted it to. After that, you can see them in there and adjust them just like you want. There, we're seeing how they're loaded on the machine. Now, with 2019, you can see over here that you have the tools that are not loaded in the turret. And then here we're seeing that we have the station here, okay? So what they're going to do is they're going to see those two tools, and they're going to say with a simple button click to auto load those tools. It's put them into that station with the, put them into the block with the double station. Then they can come in here, view them, adjust their projections, and get those set up just like they will be out on the actual machine. Okay. So with the mill turn, we now have the ability to have a no motion for a reference position. So what would happen in the past is your machine would want to rotate back in some cases, like we see here, back to B0 before coming in and doing the cut. So what we now have added is the ability to put in the moves in the middle here where we can tell it to go to the reference position but keeping your B-axis in the orientation that you want it to be while you're moving that axis around. So once they have that set the way that they want, we can go and see how that's going to affect that program, whereas before it was actually colliding with the sub. With the new setting here where we have those references that do not move the B-axis, we can see how that same simulation looks here. So the part is drawn out. The B rotates now to the 90 degrees prior to moving into position for the cut, avoiding that collision that there was before. All right. We also have the ability now to use the work offsets in the mill turn, and we have the ability to apply them automatically like we can across other products, where we'll auto increment from one work offset to the next, giving you better flexibility when you're looking at making adjustments to your parts as they run. And we can see there that it is outputting with the new work offset. Now, mill turn has also implemented the ability to use single turret machines. So the mill turn product is no longer just for full mill turn machines. You can use it now with your lathes that have CY axis. And what you're going to get out of that is you're going to get some of the advanced functionality that comes with mill turn, the ease of job setup. You also get the simulation and the ease of the part setup as well. So what we're going to see here is a part that was used for the single turret, and you can see how easy it is to go down through the basic job setup, just like it is with all of the visuals that you get when you're setting that up for your single turret machine. So you can take advantage of those things that are available that were previously only available for the mill turn. You can now take advantage of those for your single turret lathe. Okay. And you also have the ability to support other types of tool paths. Again, it depends on if you have the lather or the lathe and mill. The single turret bar feed, you get the same benefits that you get with the new enhancements for the mill turn product for bar feed. You can also apply those to your single turret lathe. So as we're going to see here in this animation, you can, even on your single turret lathes, get that part out a specific increment from your chuck jaws and do your turning on here as well as your parting off with full simulation of that. Okay. Speaking of the mill turn simulation, it now has the ability when you're going into that simulation to start that up at the last view that you had. Previously, the view would reset every time you exited and re-entered the simulation. Now it's going to have the ability to save that, and when you re-enter simulation, you'll be in the same orientation that you were before. Okay. We're going to move on now to some of the milling stuff. And we will start that off with the new way that we have to select holes. So they've added in a new hole definition manager here. So when you're selecting points for drilling, the selection method on those has changed some, and it's actually gotten significantly easier, and it's got some more intelligence built into it. When you're also selecting geometry, you have the ability now to use the guided chaining. So guided chaining, when you're doing linked solid edges, you no longer have to walk out in the graphics area around the part. You have a couple of simple buttons that will allow you to complete that chain. All right. With the roughing, you now have the ability to skip pockets smaller than a specific amount and give you better control of your roughing toolpath without necessarily having to have boundary geometry or stock geometry to get the result that you want. Gives you a little better control over your roughing paths. We also now have the high-speed scallop. It's an equal scallop that gives you a little better, smoother motion than the methods we had for doing this in the past. And what we would see in the past without the high-speed equal scallop is when you would get close to a vertical edge, that step over could sometimes become slightly erratic. And with the new high-speed equal scallop, we now no longer get that in most cases. And we can chamfer solid models. So what this does is it's very similar to your standard chamfer, except it has the intelligence of recognizing the entire solid when you're selecting your geometry. Let's take a look at a couple of these things. In Mastercam, and we will start with the hole definition and hole selection. So what I have here is I've got a part with a bunch of points on it, and I want to use those for drilling. So if I come up here and I select drill, it takes me into my new toolpath hole definition right here. In this particular instance, let's use window selection. So I'm going to go ahead and window select. Let's take those right there. Now, what we can see here that it didn't do before is it automatically not only selected those points, but gives me a preview of how that sorting will look. Now, what we would have to do in the past is when we added a point, we would then have over here in our features a list of 1 to however many points. And if I added this point way down here, it would put it at the end like it has here, which is great. But what if I add this point here in? Well, in the past, it would put that point after this one and basically put them in order. Now, when I select this point, it's automatically updated that for me. So every time I select the point, it is changing the order here and putting them in the order that is most efficient based on my sorting option here. That means that I can select those. I can come out here and select these for my window selection. I can add that one in. Maybe I'll add this one in after, and I can put this one down here in there also. Now I can still come in here and change my sorting method here. You can change that to anything that I want. You can select clockwise and get a center point there. And we can choose any of these methods that we might want. And again, the nice thing is every time we do these, it's going to take and update that for us automatically. And if we go and add points at any point in time, it will put them in there the way that we want them to be, which is very nice and very easy to use. Okay. So now let's take a look at the skip pockets smaller than. So let's open this model here. All right, so what we have here is we have a surface high-speed operation. Currently it's going in here and it's cutting out all these pockets for us. Well, in certain instances you have a tool that is large enough that you may not actually want to rough some of these smaller pockets with it because you might be in a condition where there's not enough active motion, or you'll end up with the chips not being able to evacuate fast enough. What you can do is we can come in here into the parameters here. Now, the skip pocket's smaller than, if you're going to look for it on the cut parameters page, but that's not where it's at. It's actually on the transitions page. So you need to select transitions, and then it's right down here, skip pocket smaller than. Now we can see here that what we have is that set right now to 300%. Let's look at what happens if I set that to 380% and then accept that and reprocess this toolpath, and we're going to see how that changes what we're looking at. Okay, now with that change, we can see that it has now eliminated these smaller pockets that do not meet the criteria that we had selected for that. Okay, let's look now at the model chamfering. Well, if we have, and we were going to chamfer these edges around here, in the past what we would have done is we would have selected contour, right? I do want to use my solids chaining, so let's do some linked edges around here. All right, we'll start here. Now, this is where we see our guided chaining. With the guided chaining, I can switch the direction here. So that would be going down or across the side. Right here, this button here is the next. It's going to follow the red arrow around. So I can simply step through these edges until I get where I want to be, right there. I don't want to go any further than that, so I'm going to go ahead and select OK. Now we'll come down here to Tool. Let's use this chamfer tool right here. We'll go to our cut parameters. We can change that to a 2D chamfer. Yeah, let's do a bottom offset, and we'll do a chamfer width of 1 millimeter. All right, we'll accept that. And what we see here is a tool path, right? We got our chamfer in. All right, hey, that looks pretty good. Well, hold on. Because when we backplot this, like we're going to see here, we got our tool plunging down and plowing right through the edge of our model. Look at that. That would make a very delightful noise. We can come around here and we're seeing the same thing over here. It's violating that edge. So what I would have done in the past is I would have broken this up into multiple chains. Okay. I would have come into the parameters, broken it up into multiple chains, and then came down to lead in and lead out and modify these using extend, adjust the start and end of contour to change it. Well, let's not do that. Let's come up here to our toolpath type and let's select this new model chamfer. Okay. So I've selected model chamfer using the exact same geometry that I was already using. I'll use the exact same chamfer width and settings in here. What I will do is in my lead in, lead out, I'm going to modify this fitting distance and I'm going to change that to 2 millimeters. We'll talk about what that fitting distance is in just a moment. Okay. We'll also change just for the sake here, we'll change these to a smaller amount for lead in and lead out. Now, we're going to go ahead and accept those changes, and we're going to reprocess that. Now, remember, this is the exact same geometry that we were using with that chamfer tool path that was violating our model and interfering with that. Now, what we can see here is we've actually got it to where it is using some intelligence to avoid those areas that we can't quite get to. Let's take a look and just see how this looks. So let's select that one that we want. We'll backplot through this now. So when we're plunging now, we're actually avoiding that. So we're not actually plowing into the wall there. We come around here and it's going to stop. Lift up, move over, re-enter, and not violate these walls on the model. So what we have there is we have a situation where we took the geometry we were already using and we applied that to the model chamfer and avoided those collisions. So what it does when it's going through there is it actually looks at the solid edges, but when you select those solid edges, it actually recognizes the entire solid model. So it knows where your tool is hitting there and how it's coming across, and avoids those solid walls like we had there and we had there. So now let's take a look at a different file. We'll look at the equal scallop. As we can see here with our equal scallop toolpath displayed, when we're looking at this, we see that even coming into these corners, all these passes are very equal, very smooth. The step over is the same, even going across steep surfaces. We can also see if we were going to backplot through this, that as we come up against these walls on the outside, we're still following that essential profile. So if we were using a different method in here, such as a parallel or even a flow line on these floor surfaces, when it got up here to the edge, it would not handle that nearly as good as that equal scallop does. Going about it in that routine and that method, when we get up here to these edges, we will no longer have to take and do an additional operation such as a finish pass or a pencil trace along those edges in order to get a nice finish around the sides like we would want. Okay, let's talk a little bit about the ability now to check the holder. Now, you could check the holder in 2018 as a C-hook. It's always been available there as a C-hook that you could use. But now what's happened is that's now integrated into the Mastercam interface. It's under the utilities. You can see that right over here as check holder. Now what it's going to do is it's going to look at the tool that you have selected as well as your operations, and it's going to come through there and calculate that tool projection for you. And then what you're able to do is modify that accordingly. All right. For the multi-axis stuff, what we have now is accelerated finishing. Accelerated finishing stems from Mastercam's new ability to use taper tools, barrel tools, and things of that nature to do your finishing around the outside of your part in your multi-axis tool paths. So if we're looking at a part like that and we have those tapered edges, what we would have done in the past is we would have used a ball end mill, and then we would have had to take a lot finer step over to achieve the surface finish that we're looking for on that. We no longer have to do that because we have the new tool support. Now, after you're done with all that, you'd probably want to come in and deburr your part. Well, one of the things that we've added in the multi-axis now is the ability to do a model deburr. When you're doing the model deburr, you're actually able to select the entire model, and it will select the edges that it can and break those edges for you with your multi-axis tool path. You can also limit that to the specific number of axes. So let's take a look at a couple of these things here. We'll see how they work. So when we're looking at the accelerated finishing, what we would have here is this is how it would look if we were going to go and finish that outside with a ball end mill. You can see here that we have a bunch of different passes going down the side, and it would actually take quite a long time to achieve a reasonable finish on the outside because we would have to have quite a small step over. Okay, but what we're able to do is we're actually able to use a tapered end mill on that. We can look at that here when we go through and step through here. We can see we're actually using a larger contact point across that tool, which means that when we're running that, we actually need fewer steps down because we're able to use a larger contact portion of that tool. But what if the surface is such that you can't actually use something that's flat, if it's too complicated for that? Well, you can also use a barrel nose tool like we're doing here within this area here where a tapered tool wouldn't quite do the job. So we can look at that and we can show our barrel nose tool coming in here. It'll get these internal radii like we want, but we also get the added benefit of the larger effective radius here, meaning that when we're doing our step downs, those step downs can actually be further apart, and we'll be able to cut time out of that and still get a finish that we would like to get from that. Okay. Once that's all done, you're probably going to want to do some deburring and things of that nature across this to get rid of these sharp edges on this part. So if we look at our deburr option here, we've got a deburr that what we did for geometry was select the entire model. Now it's come in here, we've got this one limited to 3 axis, and what it's done is it's come in there and identified those sharp edges We'll come in here, it'll pick those edges. Now this does only work with ball end mills for the multi-axis model to burr. And it will go through and select those edges and get those regardless of whether or not they are two-dimensional or three-dimensional. It can sometimes move around a little bit and do some extra lead-ins, lead-outs, but that's what you get with the intelligence that it has for making that so much faster. The amount of geometry and the type of edge break here, if we were to do it without the model to burr, would take a significant amount of time. With this, like I said, it was just a model selection and we got where we wanted to go. All right. So now let's talk about, after you get all this done, what are you going to want to do? Well, you're probably going to want to do some simulation to see how it's going to look on your machine. Well, with 2019, what we have is we have some new simulation tools such as toolpath analysis. So now what you're able to do is you're actually able to look at that toolpath and look for things like how fast are some of these motions. You can look at the timeline and actually change the scale that you have with your main slider by using the timeline zoom to get a little bit more accuracy as far as where you want to be with looking at very specific operations. Okay. You can analyze your toolpath and actually sort that with the different options. You've got feed rate, plunge, segment length, and it's going to change the colors of those things and show you a visual of those on the screen, and you can see how that will look to really get in there to the specifics that you want to see. We also now have the axis simulation control. It looks a little different than what we've had in the past. In the past, we've had a bunch of different sliders. Now we have something that looks more like a jog control would out on your machine. They've got a little setup here of it. You can see it would usually appear over there on the side. We're going to take a look at that within Mastercam here in a moment. Capture and replay. So capture and replay actually allows you not only to do your back plot forward, it actually also allows you to, when you're stepping backwards, put the material back on. So that way you're not in a situation where if you're into a long detailed simulation and you miss the section you want to see, you have to restart the whole simulation to see it. You no longer need to do that. You can step backwards, put the material back, and then see the area that you're most interested in. Okay? So what we're going to see here in this short video is we're going to see how that capture and replay is effective and how we can actually watch that, cut, and then put the material back in place if we need it to. So you can see here we are removing the material. And then when we get to the section where we actually need to go backwards, we can, and we'll be able to take that backward. And when we do so, you'll see that material will actually reappear. Okay. So with the machine simulation, which is now integrated into Verify in 2019, what we needed to add was the ability to change the transparency of your machine so that you can actually look through it and see your part. You had machine simulation as an option in previous releases of Mastercam. However, you did not have it integrated into the verification like it is now. With that integration comes the need for making that machine not just transparent, but you can also make the machine invisible and still get the benefits of seeing the motion as it would be with machine simulation. And we've added stop conditions. So not only can you stop at the end of operations and collisions like you could before, you can now stop on specific operation numbers, specific tool numbers, or specific X, Y, and Z values, as well as steps if you wanted to. So let's take a look at a couple of these things in Mastercam here. So we can pick some of our operations here, and let's go on into our verify. Now, before we go into verify, let's look at the setup options right here. Okay, so with the simulation options, what we now have is we now actually have the ability to use fixturing, not just specific models, but from a level also. So if we go in here and we can turn on our fixture, we can come down here and we can select our work holding. We can also come up here and select stock from various options, such as stock model, file, stock setup, or solids. In this particular case, let's look at the stock setup. Once we do that and we go into our verify selected operations, that will open up here so that we can look at it. It's going to automatically load our material as well as our fixturing. So when we look at that here, we'll see it sitting there. Now, up here under our mode, we have the backplot. We also have verify, and then next to that, we have simulation. So if we click on simulation, what we're going to see is we're going to see it actually put that and bring the machine open. We can rotate that around like we would before. We can go ahead and maximize this. So we can rotate this around. We can see, like we were talking about, your machine housing up here and the whole machine. What you can do is actually change that to transparent, like so, or if you click the machine again, it will become invisible. One more time, of course, and it's back and looks like so. So on our slider here, we have several options. You still have the performance, precision, the slow, fast, just like we would in the past. We can run through this here just a little bit so that we can look at some of the things that we have. So we're going to go ahead and pause that right there. And we're going to look at the machine control. So how did that work? Well, we can come up here under our simulation tab and we can do our compare. But if we want to look at the machine control and various things, right now, currently we have our move list open and our collision report. Under view, we can turn on our axis control. For our axis control, we have more of a radio dial like we used to have. We can switch this to our Z axis. We can actually grab this handle and jog it in a way like we would. We can adjust the rate of jog here. So we can now raise that up. Okay, we can switch that over to our X axis and we can jog this back and forth using the dial here. Okay, we can also move it using the plus and minus buttons here, like you see there. Okay, we can also adjust over here. We can adjust our rotary axes and we can make those move within the limitations. It'll even show us during these manual moves if we're colliding. So the collision detection is still showing even though we're manually moving our axes around. Okay. Now, let's get that back to where it's not actually colliding with anything. And we'll go ahead and close the axis control there. Let's look at the toolpath analysis tab. Now, right now, our toolpath analysis is set to none. We can look at operation, just like we were talking about earlier. It's telling us which operation will show up as which color. We can look at, set that up and break it down by tools. We can also break it down by feed rates and so on and so forth, and even segment length if we wanted to see it displayed like that. Okay. We've been able to save geometry from the backplot menu for a while. So you could save out your backplotted toolpath geometry and use that for other things. With 2019, we now have the ability to save the tools as geometry also. You can use that for your measurements or for other things that you may be doing with that. Now, when you get this stuff all done, what you really want to do is you probably want to put together some documentation. Well, with 2019, we've expanded what we can do for our documentation. And one of the things that we can now actually support is AutoCAD's paper space. And we can also export to the STEP AP242 protocol. And we can also use the BREP data for boundaries. For the levels, you can turn them all on and all off with the buttons that you have here. But one of the big things that you can now do is you can actually cut and paste from one level to the next. You also now have the ability to use and modify the gnomon for your plane. So in the past, if you were doing a very large part and your gnomon size was fixed, what you would get is you get the situation where sometimes you can't see that gnomon. Well, now what you can actually do, as we're going to see here, is you can actually change the size of the gnomon. You can change the color that the grid for that particular plane will be. And like we're showing here, you can actually change the size of the axes on the gnomon. You can then choose to display the plane, show the grid, and change the size of that plane as well as the opacity of that and make it more transparent or not. Doing this, it allows you to see the planes a little more clearly when you're going through and programming your parts. You can also turn those planes on and off and have them visible at any point in time that you want. They won't automatically disappear if you don't want them to any longer. Using that, you can get a little bit better view of what you're doing when you're moving stuff around and collecting that data to use for your documentation. You can now use the section views and views in your view sheets. So your section views can also be used as part of a view sheet, part of a setup there. You can use those pictures also for your setup documentation, and it will help you see the things that you need to see when you're setting up your machines. Go along with that, they've also improved the ability to add a little bit more information to that. We can now change the type of pictures that you have and enter extra information and have that come out as part of your XML setup sheet. So what we've looked at is we've looked at some of the new features, not everything, that is in Mastercam 2019, all the way from the preparation through the documentation. This is not by any means everything. I would highly recommend that you look at the What's New PDF document if you would like to see all of the new enhancements that go along with Mastercam 2019. Again, my name is Joe Brooks. I'm with MLC CAD Systems, and I'd like to thank you guys for your time in watching this presentation. Thank you.